Good morning, everyone. We are in week 2 of this workshop. This week, we're going to talk more about fused filament fabrication and then SLA and DLP patterns for investment casting. Next week will be PMMA and wax 3D printing. And then the week after that will be our final workshop, and that's going to be mostly on designing for investment casting, some basic design tips, stuff like that is useful for 3D printing patterns. Real short PowerPoint today. It's only going to be about 5 or 6 slides, and then we're going to start getting the demos right away. If anyone has any questions, feel free to type it in chat, and I'll answer it when I see it. So let's go ahead and get started. So first thing I wanted to talk about, I brought it up a little bit last week, but the importance of infills in FFF and SLA and DLP. For your SLA and DLP patterns, usually there's some sort of internal structure that comes with the printer. If you buy a 3D Systems printer, they have their quick cast and quick cast diamond infills. Those are pretty much set. You can adjust them a little bit, but they're set to the printer itself. With fused filament fabrication, you have a lot more options. Usually there's at least a good list for me to pick from and use. Here's just some typical ones that come up on some standard prints, and you can see the differences by changing the infill density. So the 20%, you're having real light infill, and then as you increase it, it becomes more and more dense. It's almost like a solid block and less like an infill pattern, right? But this is largely going to affect how the pattern burns out, mostly in terms of ash content. If you're running an 80% infill, it's basically solid, so the weight of your part is going to be higher. So even if the filament you're using 0.1 or 0.01 ash content, let's say, you put 1,000 grams in there, or at the 1,000-gram pattern, it's still going to have 10 grams of ash afterwards, right? So doing an infill pattern is going to have less weight and less ash based on that burnout. Clicked on the thing. Sorry about that. In SLA, it's going to matter more so. That material tends to expand more. So a lot of the infills of those patterns are designed specifically to either collapse when they start to heat up or fail earlier, so they have a smaller chance of cracking the pattern. Not to say that fused filament won't expand, it's just SLA tends to expand quite a bit. And here's just some data to support this. We did some testing on a new resin that was going to be coming out for a 3D printer. We tried a bunch of different structures. So we did 4 different structures here with a varying shell thickness. So E has a shell thickness of 0.75 millimeters, and the shell is the skin of the pattern. And then the lattice diameter also varied, and that's the struts inside. So if, let's say we did like a triangle grid, each of the struts in there is going to be 0.75 millimeters in diameter. Then GH and I were all 0.5 shell thickness with a varying lattice diameter from 0.5 to 1. You can see in the results that structure E is going to expand a little bit more than GH and I will. But since GH and I, you'd think since they're expanding less, you want to use that, right? But however, I have a little example. This one was, I need to see my camera so I make sure I have it on there, sorry. So this part here was printed in that 0.5 shell thickness. And let's see, it looked better when I was doing it on my other camera. But this guy, when we were post-processing it, taking off the supports, cracked real easily. It was really flimsy. After we cured it, it regained a lot of its strength, but in the initial taking out of the platform, pulling off the supports, it cracked. So we kind of have to strike a balance here between how thick our shell is and how okay we are with the shell expanding. We ended up finding out that E structure there, that 0.75, is a pretty nice middle ground for strength and expansion, because the next shell thickness we tried was 1 millimeter, right? It expanded significantly more. We did do some casting with both the 0.75 and the 1 millimeter. The 0.75 didn't crack at all when we were flash firing it, but the 1 millimeter shell thickness, there was some hairline cracks on the same part. That could be a lot of results, but it was becoming fairly consistent. It was expanding a little bit too much for our shelling process. So we settled on that 0.75 for that particular material. And I swear this is as wordy and numbery as it's going to get today, probably. So some general things to have for post-processing. For fused filament fabrication, there's a whole lot of stuff you can use. There's whole 3D finishing kits on Amazon that you can buy. 90% of what we use is flush cutters that are shown on the top left and sandpaper. That gets most of everything that we print. And if there's something really complex, we use a PVA material, like the one shown on the right, that little white support structure on those prints is water soluble. So if you throw it in a vat of water, it'll dissolve over time. Don't have to snip off any supports. It's really helpful if there's like deep crevices that you can't necessarily get to with cutters or anything like that, but you still want to pursue a fused filament route. Other things we've used, like clay modeling tools we've used before. What else? Oh, deburring tools are nice if there's any like small holes that you want to deburr, things like that. Pretty much anything that you have in your shop is probably good enough as long as it's not a big, end mill. Those will probably chip it, but you can make most things work. For SLA and DLP, you can use a lot of the same things, but there's additional, I'm going to say, requirements for post-processing where you can, with fused filament, you can get away with flush cutters and sandpaper for a lot of stuff. The SLA and DLP printers, the resin afterwards needs to be cleaned off and drained if it's a hollow pattern. So for instance here, the Formlabs printers, they come with a cleaning station and a drying station. Most of their patterns are traditionally solid though, so dipping it in a vat IPA to clean it off works well. Then you can throw it in the curing oven afterwards and it'll be good to go. But if you're doing investment casting patterns, you're typically going to print these shelled out. And we found that there's some issues if there's IPA or isopropyl alcohol in your pattern when you go to cure it. We found sometimes it'll actually weaken the pattern if there's a lot in there. It'll heat up, vaporize, and do some structural damage to the actual part. So we like to just use rags and paper towels to wipe off all the excess resin, and then we'll put it in the curing oven once it's fully dry. And another thing that if you're doing SLA and DLP is you'll need these like some sort of UV spotlight touch up to clean up any vent or drain holes in your patterns. We'll talk a little bit more in the demo section about that, what they're used for if you're not familiar with the process. Other part, I will use sandpaper to sand down any support attachments. If there's any overhangs, we can use, or if there's any holes, you use the deburring tool here as well. You just got to be careful not to go all the way through the skin and let the slurry slip through your pattern when you're dipping. Now we're going straight to the demo section. I'm just going to leave that up there while I switch screens real quick. We are going back to Cura. So let's say we're going to set up a little typical impeller here for casting. Nice little guy like that. Nothing too special. You probably have a part that looks almost exactly like this in your shop, if I had to guess. But when we drop it in Cura, there's going to be a couple things we will notice. Right here, the red spots, those are going to be spots that are likely to require support by the software. In this case, for this particular impeller, I don't think we need them. Since the slope on these curves is so, I guess the word I'm looking for is subtle here, it'll probably print without the need of supports. And that's really going to help us in the printing this part. We're going to not have any rough surfaces on the inside of this that we really have to sand down the finish. Excuse me, sorry, I'm just getting over the cold. So we dropped it in. We have our printer selected, whatever that may be. I'm just going to print this in a standard PLA for now. So this is an impeller. There's probably going to be some tight tolerances here. So for profile, I can select different, it's basically selecting the layer height. In this case, we're going to do extra fine. excuse me, just we're going to reduce our layer height, and it's going to make the layer lines less prominent. There'll be more layer lines, but they'll be smushed closer together, so it'll look a little more smooth. And I can just for a comparison, here's the preview on Cura is pretty nice for getting a close look at what supports are going to look like, for instance. So that's kind of what our layer lines are going to look like at 0.6. Let's say we do like extra fast here. We can get a quick side-by-side comparison. So the divots are going to look a little bigger, but there'll be less of them. Kind of a game time decision on what the part is and what your requirements are for surface roughness and things like that. But if you're trying to get best surface finish you can on fused filament, keeping your layer height as low as possible is your best bet. Now, when I'm looking at this, these supports here are really bad. They're probably, if we actually printed it like this, these are going to be pretty rough to remove, I think, with just flush cutters. You might need some needle nose pliers to pull all this off. But like I said before, I'm not sure that we even need supports on this. And in fact, I printed this on a printer before, a few FFF printer, and I know it doesn't need it. The slope isn't extreme enough. It's hard to give you a number to say, yeah, you probably don't need supports here. It's just kind of one of those things that's still kind of a gut feel after printing so much. One other thing we need to look at when we're setting up this print is we're going to look on the insides of it. So right now, I have 3 wall layers on this inner cone here, and there's a little hex supporting it. Now that's definitely enough to support that middle structure. If we were, say, down to 2 wall lines, which is one of the settings that I kind of showed last week, let's take it down to 2. Now this is we're kind of getting close. It should be strong enough to survive, but we're kind of in a tweener range where, like, if you like slam it into a wall, it's probably going to snap off. That extra layer will add a little bit of weight, but it'll give it a little bit of more strength when we're post-processing it. But since there's no, we're not going to print any supports on this, we're going to leave it at that 2 wall. We're not going to be handling it very roughly after it's done printing. We're probably just going to, in this case, I would take like a little blob of, like a PMMA cube, like a 1 inch by 1 inch or 2 inch by 2 inch, and stick it on a tree or something like that, wax blob, anything like that we can attach it to our PMMA trees. So this one, pretty straightforward setup, not too much to change here other than we turn the supports off. But let's get to something a little more challenging and something that's not necessarily conducive to being printed on a typical 3D printer. So this house right here, can't see it well. This is a house based on a fantasy book race, not to be disclosed in this workshop, but you can see on this print, there's a lot of overhangs on this canopy here, the edge of the roof. If we print it just like this, it's almost certainly going to look terrible. Let's give it a preview what the supports are looking like. Oh, we have support turned off. That's probably good. So you can actually see what it kind of looks like. Typically, anything that's white on here, by the way, is like a endpoint where the nozzle is. So that's kind of a retraction and drop off point. They don't actually look like that on the printer. They usually look pretty seamless on our printers, but let's generate some supports. So as you can see, all that blue, that's all support material that we're going to have to remove if we were to print it like this. So obviously, this isn't exactly a part made for FFF, but there's a few things we can do to alleviate this. So in this case, there is a a support blocker that you can use to block support locations on prints. Unfortunately, on this one, a lot of them are pretty much required just for it to actually print. But there is one simple thing we can do here. We can kind of, if we look around this face of the building, if we were to print it on this side of the face, all the supports would there'd be a little bit up here and a little bit on this section right here. And other than that, it wouldn't be too bad. Let's give it a shot. Let's see what it looks like. Ooh, it doesn't like this one. All right, let's take a look. Now this is reasonable. The last one wasn't reasonable. Big long sections of support like this one, the ones that are really tall, tend to come off really easily. You just kind of start pulling it, and it'll come off like kind of looks like a slinky when you're pulling it off. Comes off real nice. Little sections like this inside of the chimney here might be a little tough to remove. But if we were to grab this edge here and pull it out, we might just have to get the flush nips in here a little bit and trim up the side. And this is a pretty non-critical part up here. This would be more if you're working on an art piece, right? You have some flexibility on dealing with this. And really this chimney is almost certainly not going to work. Almost this support is not going to be enough to hold itself up, I think. What can we do to fix that? I just now noticed that one from before. Something like this, we might have to go into our model and add something there to help it build this from the build plate instead of trying to stick out from here. Everything up here is pretty reasonable. Most of this up here we can get out pretty easily. The only issue might be the staircase. That might be pretty tough. It might break the post as we're trying to remove it. But if it's better, it's much easier to glue this post on afterwards than trying to glue everything back together if we were to print it the original way. All right. I've been talking fast again. Does anyone have any questions yet? If not, hold on. We will switch. Oh, sorry, there is a question. Tree supports. I have not used many tree supports. Let's see. Most of my, let's see, I'm thinking I have, but it was before. One second. I think I do have an example somewhere on my laptop. Don't mind me just searching. I don't have the model on my laptop. I have used them before. I do like how a lot of them tend to they snap off pretty well. Let me pull up a image so in case people don't know what we're talking about. So it'd be something like this. Oh man. Here we go. Hopefully you can all see that, but they're a more organic looking shape. I think Ultimaker Cura does have. I'm almost 100% sure they have support for this because Ultimaker owns Cura. So I haven't set it up to use these. In previous experience, and we're talking a few years ago, they did come off quite nicely. Sometimes they can get a little crazy. And this one in here, it looks like this is kind of looping around this post. So you'd have to snap that off at that branch. Not too big of an issue. Let me just see if I can set it up on here real quick. I think it's default, but I might have to download something. Ooh, it's not looking. Here we go. One thing I didn't mention last time is in these settings, these are kind of the basic settings. If you were to go to these sliders, there's a whole lot more settings that you can actually enable. Let's see if we can get this going real quick. Didn't like that, did it? Come on. Well, then where'd it go? There we go. Let's try it. Let's see what it looks like. I imagine in this case, this one's going to be a little rough. There's a lot for it to. Oh, that's not terrible. These down here, this section might be pretty tough, depending on how well it adheres between the tree and the layers, but this one will be pretty easy to remove. This guy's not bad either. This guy's pretty good. It's fixed that overhang from before. If I can, I try to avoid really short supports like this because they tend to just be a big glob at the end and they like to stick to the part. But I'd say probably both of these cases you'd have from the original supports that we did to this, you're probably going to have a similar amount of pros and cons, I think. I'm going to print it today just to see for sure, but they can definitely be useful in a lot of parts. I don't know if I answered your question. I mean, it was more of a ramble and a rant than anything, right? But yeah, there's a time and a place for them for sure. Okay. Let's move on to a little boop. So let's move on to some SLA stuff. I have access to a few here. We're going to look at both 3D Sprint, which is 3D system software, and we're going to look at Freeform, which is Formlab software for send up prints. We're not going to spend too much time on these. We're going to spend more time afterwards in Materialize Magics because there is an alternative to using their infill slicing softwares. So you haven't used this. This is the 3D Sprint software. A lot of similar tools. This guy, we're going to do the same impeller. Looks like it's scaled wrong in here. Once we drop it in, we can click on prepare here. And then we can scale it up and transform. Let's just say 200% for now. And then we move it back to the print. So now we will auto place it and it should put it pretty close to the center. And then we're going to orient it, manual, and we'll click on a face. Same setup as before, really. Just a couple more SLA specific issues. So the big difference, we're still going to infill it like a fused filament pattern would. The big difference here is this resin is significantly more expensive than the filament. So we're going to try to save as much as we can. So definitely not printing this solid. So that's what there's a vent drain tool here. Vent to let out any air trapped in here. That one's a little small, so we're going to delete that one. We're going to move this down to about 1.5, just so I can fully fit it on the tops of these impeller blades here. Vents are important for the top half of the part, just so if any air gets trapped up there. I was working with a manufacturer that said they had some parts like explode in the print bed due to trapped air when it was printing. Not like a full-scale explosion, but there was a pop and some gas release really quickly. So all these small holes here, are just the vents. You can see when we flip to the bottom side, it'll automatically switch to the drain section. You can see they're a little bit bigger. This side is going to actually drain out any excess resin after we take the parts out of the print bed. Pattern wise, this one's really easy. We just want to make sure there's enough holes for the resin to be able to run out. This one, some patterns you might have to tip to an angle to the side, whatever, to get it all out. This one's going to come out pretty easily. And even these vent holes on the top will act a little bit as a drain hole as well when we take it out to remove any excess that gets in the blades. I do want to commit changes. Yeah, so I don't have to do that again. So I tend to I probably have too many vent holes in here, to be honest. But I'd rather have too many than too few, because what we're going to do after we print this is we'll just patch them up and it'll be good to go, really. The only other setup in 3D Sprint we need to do is supports, which is just a smart support here. I usually do dense. The supports are going to be pretty simple on this. The nice thing about these supports is compared to the fusible ones, these come off real easily. If they're still kind of soft when they're coming out of the printer, they're not fully cured. So this bottom part I can just peel off with my hands. And then these guys I can break out pretty easily, or I can just snip them off with some flush cutters and maybe just hit it with a little bit of sandpaper if I don't get it all in the first snip. SLA is really good for these really complex parts where there's hard to reach but still reachable locations. We can still pull this stuff out pretty easily. The only really other setting that you'll maybe touch is build style. So right now it's set to do quick cast, which is their infill. It's kind of similar to like a hex pattern with a bunch of trees connected to each other. They have different ones. You can edit it to change different things. Like if you want the pattern to be thicker, you can add additional borders here. It'll add a little bit of weight and material, but the patterns will be more firm and able to deal with post-processing. The way we have, I think we do 5, which gets us roughly 0.6 millimeter walls on the SLA prints. And that's good for most things. If it's a really big part where there's lots of big, long, wide surfaces, then you might want to bump that up, because any like flat sheet over a long distance tends to be a little more flexible than its other parts. Once you get into a curing oven, though, it tends to be good. No, don't discard my changes. Fine. The other thing you can change, recoder. There's a recoder blade in the Pro X800 that we use. Sometimes we'll slow this down so it doesn't knock the part off the build plate while it's printing. And last thing we usually do is estimate. It'll give you a print time, material used, and you send it to your printer. Post-processing for a guy like this, flush cutter to snip all the supports off. We'll use paper towel or rags to wipe off the outside with IPA usually. We'll make it so you can tell pretty easily if there's still some resin on there. It tends to be shiny, and once they get closer to clean, it becomes more and more opaque, similar to this guy. I don't have an unclean example for you because they're messy and we don't leave them unclean for long. After we cleaned off all the IPA, we'll usually take an air gun and stick it in one of these drain holes, and we'll air dry it just to make sure we got all the alcohol out of there so it doesn't damage the part. And then we'll put it in our UV curing oven. For this guy, it's like a 15-minute stay in the oven at most. Larger parts require a little more time usually. Excuse me, sorry about that. There's less flexibility in general on SLA parts. They tend to pick their own infill, so you can't complain about, choosing the wrong one on accident. So um, you can always, we've asked 3D Systems to change some stuff for us before. For instance, I'm sorry. Well, we the layer thickness is set to 0.125. We wanted it at half for a certain part, so they sent us a special code that we can plug in here and let us change that. We were able to change like the maximum amount of borders. I think it maxes out at 20. Yeah, max out at 20. We set it to, I think we were trying to get it to like a 3 millimeter thickness for a certain requirement on a part. But they're helpful, and they'll give you special codes to update stuff like that. Please just let me close. I'll show you the house real quick, actually. That just for, I need to scale this up again. Scale by 200%. So I have this Hobbit house at my desk actually. And I did print it in hollowed out SLA. We were trying some new software that we're going to talk about here in a little bit, but this part is really great for SLA prints because there's so many overhangs and things like that. I need to, oh, embarrassing. Sorry, clicked out of everything. All right. What's really nice about this, so since the supports are so much fragile, I guess, removing this and post-processing this is way easier in SLA than it would be in fuse filament. Let's just take a look at the supports here. Most of this can be ripped off with your hands, and it'll probably come off in a bunch. Most of this will as well, and everything else is some snips and a quick sandpaper rubbing away from being ready to go. However, it's going to be about 10 times the cost. So you kind of have to pick your battles. Anything on this section before we move on to Formlabs? I'm going to start switching over. Check the questions. Make sure I'm sharing the right screen. Preform. Yep. Okay. So we recently did some research with Formlabs on one of their resins to see if it was applicable for investment casting, and it worked out pretty well. So that would be a cheaper option going forward than compared to 3D Systems. Like the Pro X800 is significantly more upfront cost to start with that. Although you can print larger parts faster on it. There's a certain threshold that you have to cross before it's afford or reasonable for you to buy one, as compared to a Formlabs 3, I think is a couple grand compared to the 6-digit number you might have to purchase from 3D Systems. So it might be a little bit more generous on the wallet. So we'll throw this in here. One problem, though, that they are working on is that there is no software to shell out your pattern, which is an issue. They have been working with some people to a low cost self shelling part. So if we were to upload this print right now, it'd come out as solid. It has the same thing, generate supports here. So how do we get this printable on printers that don't have their own infills set up? Well, this is how we've been doing it at the university for a while. So this is one option. We're going to switch over for a second to Materialize. I know there's other options coming out on the market now that isn't Materialize, and it's a little cheaper, but Materialize is another slicing component that you can purchase. They have tetrashell ingrain, which is a pretty common infill setup for SLA and DLP. Let me drop that impeller in here as is. Make sure I'm on the right screen. So we're in Materialize. Up here on the top right, we have the tetrashell module. Just click on that. We can set our wall thickness. We can set our detail size. I mess with this a little bit. There's pretty marginal returns the finer detail you get. So I can leave it at this 0.4, but wall thickness you can change to whatever you want. So let's just say we're going to print 1 millimeter walls. This is kind of like the SolidWorks STL fixing from before. You can change the amount of triangles present. This is where we're going to change our strut diameter. So these are pretty standard setups for the internal beams. And then finally, you can add your vents here. The nice thing about these vents is you can print them with the actual print. So there's a notch, you can add a notch here to angle it. So let's just do 0.75. Oh no, I went back, sorry. 0.75. So it'll print this little notch for you as well that you can glue in afterwards. So we'll just set this up. And we'll finish. And it'll mesh it out for us. And then we can have our nice little, wow, it really didn't make much in the internal, huh? That's not helpful. You can see a little bit right here. This might require some refinement for the size of it. So let's go back real quick. I lost it. There it goes. It probably needs to be scaled up. It's probably a little too small. So we'll keep that 1 millimeter wall thickness, but we're gonna lower these. We'll leave the thickness the same, but we're gonna shrink the length to, we'll just say 1.5 for now. There we go. So now there's a little more infill in here. It's a little more sturdy. And then we can just export this out. Now, the reason I even brought this up in the first place is you can do tetrashell parts. You can do it. You can throw them in your 3D printer and just not have it shell out the part itself. And I think what's even better than the tetrashell is they have another module in here called structures, where you can generate your own internal structures, which I think we're going to be doing some research here in the near future, where we're going to develop our own structures, test them out for investment casting patterns. And you can import these models into like the 3D Sprint as well, and you just print it as a solid rather than a quick cast part. So let me export this. It's been I haven't I haven't exported in a while, okay? Usually, here we go. Sorry. Took me a second. Export as an STL. Child. And then we can go back to Cura or Preform, sorry. Too many modeling softwares today. Just drop this in here. We can already see the internals already on this. Let's scale it up to 2. And that should scale the infill as well to what it was set before. So let's take a look on the inside. Oh, please. So yeah, it doesn't look bad. I probably realistically what I need to do is I need to scale the STL and put it into Materialize again to get a better tetrashell layout. But this is pretty similar to what we did for this actual guy. The struts were a little different size, but it looks good. This part can be dropped into 3D Sprint and printed as a solid part, and it'll come out looking just the same as this. You can do it in Cura as well for a fused filament if you want a touch or shell pattern, because I don't think it comes on a lot of Cura settings. So you could drop it into Cura, print it with a tetra shell infill as well. Tetra shell is really nice. It has a good omnidirectional strength. A lot of the infill patterns can lack strength in some dimensions. Like for instance, the grid, it works great in the Z-axis. There's a lot of structure and support from top to bottom on the grid, but sometimes there can be weak locations on the sides. Triangles doesn't have that issue. That's pretty close to omnidirectional. I think the Z-axis is a little weaker on that one. But it's more of an experiment thing. We've printed with a lot of patterns, or infill types, but sometimes the results end up the same. There's no tangible benefit right away. Because in the end of the day, we still get our casting. So after that long, almost unstopping barrage of info, does anyone have any questions? There was one. Where? Well, unfortunately for me, once again I talked fast. That usually happens. So I've gone through everything I was planning to today. So I'll just once again I'll hang out. If anyone has any questions, I'll answer them. If there's any parts you would like to have me look at and like have opinions on how to set up, I'd be glad to do that as well. Quite a bunch today. I get it. I set this up on Monday. So it's really my fault if you think about it. All right. Well, if there's no questions, I won't hold you guys up. If you do think of anything, feel free to email me. I can help you or help you set anything up that you like. Have a good rest of your Monday and a good rest of your week, everyone.